All right. So yeah, I'm assigning all your Chapter 6 homework right now. I gotta do it to all 4 classes. But yeah, I was trying to think ahead. I love being a math nerd. What are you talking about? But right now, my idea is April 22nd, and I feel like that's plenty of time to get the homeworks done while you're doing other classes stuff. We only have 6 sections this time, plus one of the lectures is, today's lecture is going to be insanely easy. So I think that timeline works. It also gives me a small window if I want to do anything extra credit-wise with your averages. It lets me do that. It'll probably be some kind of small, mini project / presentation. But let's give some people a little bit of time to log in and catch up. It usually takes people about 5 minutes to get in the stream. Also, among all the small Twitter popularity I've been getting from doing all this streaming, I've had a couple of teachers ask me for advice on how to do all this, so I've been emailing people yesterday. It's been pretty cool. Hopefully they get their stream set up and I can kind of go check it out and see what they're doing, and maybe if I can help them out or they can give me more ideas, stuff to do. Which, by the way, if y'all have ideas for things to do, things that I can do to make this process or make this class, easier for you somehow, because we have to do all online, just let me know. Okay, so dual credit, you should be seeing all of your homeworks up and live now. Remember, especially for y'all, none of your percentages changed on any of your assignments. So your test, hopefully all of you turned in yesterday, will still count, 45% of your average. Lee College is not changing anything in terms of grade books. So it looked like everybody that turned it in on Google Classroom turned it in on Blackboard as well. With 2 exceptions, which I talked to individually, but because Lee College's help desk has not been very helpful lately. They've been busy. Not that they're bad, but they're actually very good, but they are swamped right now, I imagine. Okay, so we've got a lecture to do today. So today's topic is Dual Credits Chapter 6 Section 1 lecture. Let's see how the chat's going so far. Oh, one of the questions I got via email was, how is exam 3 going to work? The reason I had to do the whole PDF thing for exam 2 is because we were kind of, we had already had this plan for exam 2 set in place, and I feel like that was one of the fairer ways to do it. Exam 3, there's a chance you'll be taking your tests on MyMathLab, which it has its own sets of pros and cons, but if you get prepared for it ahead of time, then I think you'll be okay. I just don't want to unfairly punish anyone that, because it's like I said before, if you didn't tune in on Monday, doing a test on MyMathLab is exactly like doing a homework, except you get no similar questions, you only get 1 attempt, and there's no view and example. Other than that, it's like a homework, but a lot of you rely on one, if not all of those. Omar, this is not for pre-cal, pre-AP. If you want to tune in, it's stuff that y'all have covered already, because dual credit and high school pre-cal have been on different schedules. But, I'll be more than happy to answer questions for high school pre-cal. But today's topic is dual credit chapter 6 lecture. Yeah, I'm not forcing any kind of attendance or anything like that. That's why I try to tell everyone ahead of time when I post about the stream what the topic is going to be for the day. So if you decide to tune in, great. If not, then you don't have to. I'm not. I did talk earlier this week about possible incentives for logging in. All right, Omar. Enjoy your sandwich. Incentives for logging in. I have to figure out something where everyone would need to log. Like why would you log in? Like for example, today, why would a high school pre-cal kid want to listen to this lecture for 30 minutes if it's not going to pertain to them, right? So I don't want to force attendance or provide, a bonus for it if they don't need it at all. Probably sometime next week, I'll have a day of the week where we do some kind of, generic question and answer bonus topic or something like that. And we may just do it on something like Zoom, because Zoom is free. Schedule, I did post the schedule for this whole week at the beginning of this week. I did do that for this week. I don't want to create like a Google Calendar, but I don't know. I'll decide. But at some point next week, there will be a generic something of some kind where everyone could get a benefit. And I'll take attendance on that one, and then we'll do something as far as an incentive on your grade. And then dual credit, remember, we do still have a project after exam 3 is done. And I already have a pretty good idea of what we're doing for that. You all remember this summer I went to this camp at Rice University, and we're working on right now. I have a meeting with them later today, but we're going to come up with some kind of like project-based instruction for virtual classrooms. I'm helping head up one of those committees, and probably I'll make y'all do some kind of small 2-day project or something after exam 3 is done, after we take our final, and we'll figure it out from there. Okay, so let's go ahead and start this chapter 6 lecture, Right Triangle Trigonometry. So dual credit, if you have taken a geometry class before and actually remember parts of it, one of the most common things you learn is how to do right triangles, right? Because we all know Pythagorean theorem, but whenever you talk about angles in the right triangle, you can talk about how you have an opposite side, you have an adjacent side, and you have a hypotenuse. And then we're going to learn about how to apply sine, cosine, tangent, the trig stuff that we've been doing in chapters 4 and 5, how to apply it to triangles and applications with geometry. So that's the point of most of chapter 6. Okay. So a lot of this vocabulary I don't need to cover with y'all. I'm going to drink my tea here. All right. I don't need to cover this again with y'all just because, hopefully you remember some of this vocabulary from geometry. Also, I've been talking about it as we've been teaching, this part of the class. So you've got a right triangle. It's called a right triangle because you have to have a right angle. Triangles have 3 sides, obviously. The side that's the longest side is always the side that's opposite the right angle, and we call that the hypotenuse. The other 2 sides, A and it doesn't have to be letters, A and B, obviously, but those other 2 sides are called legs. They're interchangeable as far as what you label them, how you use them in math, all the kind of things. But the main important thing with a right triangle is you identify where the hypotenuse is, because that's usually the most important side. So we have our 6 trig functions we've been learning in chapters 4 and 5. So you've got sine, cosine, tangent, cosecant, secant, cotangent, and as we relate them to right triangles, instead of doing x over r, y over r, all the things that I've been talking about with the unit circle, when you apply them to triangles, if you just imagine you have that unit circle, and I talk about angles and reference angles, and we've been drawing triangles the whole time anyways, now just forget the unit circles there. Just think about that right triangle. So the hypotenuse would kind of be like the r, would be kind of the radius of the unit circle in this case. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent's opposite over adjacent, and then you've got your three reciprocal ones, your ones that you flip upside down. So a lot of geometry teachers teach the acronym SOH-CAH-TOA, which I have also referred to earlier in the class. And then you have cosecant, secant, cotangent, which are reciprocals, which you take sine and flip it upside down. And when you talk about sides of a triangle, you can still flip it upside down, just like we did with the coordinates on the trigonometry, the unit circle stuff. Okay. So let's do an example. Find the other 5 trigonometric function values of theta, given theta is an acute angle of a right triangle, and then they tell you what the sine is. So they tell you you have some kind of right triangle. They tell you you have some theta, which is an acute angle. It doesn't matter where you put it as long as you label the opposite and hypotenuse correctly when we get to the sine part of this problem. Now flipping back a slide, remember sine is opposite over hypotenuse, so when they give you an answer for sine, they're telling you what the opposite side is, they're telling you what the hypotenuse is. So from that theta, the opposite side would be 2 and the hypotenuse would be 5. If you had drawn the triangle in a weirder way where, you know, theta would have been up here, then this would have been the 2 instead of there. So you're going to do this a lot with triangle problems, not just right triangle problems, where you have freedom to decide where theta is, but wherever you put it, be sure to pick the correct opposite side that's corresponding to it. Otherwise, you'll flip-flop a lot of, half of your answers whenever you get to the end result. Okay, so we have sine, we need to find cosine, tangent, and then we need to find the 3 reciprocals. We are going to need the adjacent side to the angle, so you need some Pythagorean theorem here. We've done it a bunch, but might as well just write the work again. So you've got square root of 21 whenever you subtract and square root over. Okay, so now that we have adjacent, opposite, and hypotenuse, we should be able to get all 6 trig functions. So cosine is adjacent divided by hypotenuse, so square root of 21 over 5. Tangent is going to be opposite over adjacent, which we know we have to rationalize that. And I'm writing behind my webcam view again. I've got to stop doing that. Let me erase this. I'm also writing way too big. You know what? I'm just going to rewrite all this. Okay. Cosine is going to be square root of 21 over 5. Tangent is going to be opposite over adjacent, so 2 divided by square root of 21, which we know needs to rationalize into 2 square root of 21 over 21. There we go. My kids are trying to come in the office. Okay, so we have the 3 originals. Now we can find the 3 reciprocals. So cosecant is just sine upside down, so 5 over 2. Secant is going to be 5 over square root of 21. Rationalize the same way as before, so 5 square root of 21 over 21. And I don't think I can avoid cotangent hiding behind my face, so. You know what I can do is I can just move my face. How about that? Hold on. I got this. Hold on. Webcam. I've got to, hold on. This will be worth it, I promise. Let me, gotta move my face. Here we go. There we go. Now I'm just covering the title, which is fine because you can just see all my work. Oh no, hold on, I have a better idea. Let's put it right in the middle. Whoop, face in the middle. Just me having fun with my video software. There we go. Good enough. I'll figure something else out later. Okay, so let's finish cotangent. So cotangent is going to be adjacent over opposite, so square root of 21 over 2. And we don't need to rationalize anything, the square root's on top. Okay, moving on. I don't see any questions in chat yet. So this part, I guess it bears a little bit of explaining. You've got sine, cosine, tangent, cosecant, secant, cotangent. If you remember back when we learned about the graphs, they're all kind of phase-shifted versions of each other. Because if you, we'll take the easiest ones. If you take sine and cosine and you think about what their graphs look like, if you overlay them on top of each other, it's the exact same shape, except one is just shifted over a little bit. So if you think about what sine looks like, we know it starts at the origin and it does that. And it goes in both directions forever and ever. It's periodic. Cosine starts at 1, but it does the same thing. It has the exact same shape. So if you just take that cosine graph and you scoot it over to the right by 90 degrees, you would get the exact same thing. Now if you look at the mathematics behind why this identity looks this way, if you factor the negative away, you get theta minus 90. And then remember, with cosine, the negative doesn't do anything. It's an even function. So you can do something similar with cosine, something similar with tangent. Tangent and cotangent are, versions of each other. Sine and cosine are versions of each other. Cosecant and secant are versions of each other. So this is just, it's not even on the formula chart. It's not going to be asked, a lot other than some of your homework questions. But that's where the idea comes from. And really, a few of the only times you'll need it is a question like this. Given that cotangent of 68 is 0.4040, find a tangent of 22 degrees. And now I am covering my problems. Stupid webcam. Hold on. I'm just going to move myself to the corner again. This was a bad idea. Alright. I'm scooting back into the corner. Okay, so if you look back here on the previous slide, remember tangent of something. So if you just pretend theta is 22. So tangent of 22 degrees, according to the slide back here, is identical to cotangent of 90 minus 22. Which happens to be 68. What do you know? So tangent of 22 is equal to cotangent of 68. So if you just think of those angles being complementary to each other. Random corner to the top right? Like that? There we go. Oh, left. Okay. Oh, there we go. Yeah, it's still in a corner. Hey. It's very important to me that the random corner is actually in the corner. So, anyways, here for this problem, the answer is just 0.4040. Answer. Wow, that's bad handwriting, but that's okay. Oh, jeez, I just made it worse. Ugh. You get the idea. Okay. All right, moving on. So a lot of what we're going to do in Chapter 6 is, because Chapter 6 is mostly about triangles, and then later we'll get to some other coordinate planes. But if you want to find all of the measures of a triangle, that is another way of saying that is solving the triangle. So all triangles have 6 components. They've got 3 sides, and they've got 3 angles. Because we're only doing right triangles in this section, you know one of the angles has to be 90 degrees. So that, already gives you one of your 6 things that you need to find. Because the 3 angles have to add to 180, and you know one of them is 90, that means the other 2 missing ones have to add up to 90 degrees. So that's why you have this first bullet point. Complementary means they add up to 90. If you have 2 sides, you can always do Pythagorean theorem to find the third side. Depending on what information is given, you'll need to use some kind of trig function and answer some kind of, do some kind of math with it to solve something, either an angle or a side. So I gave you some examples of all the different types of things you can do here. So solve right triangle ABC. Oh, something I forgot to put on the notes. My math lab always assumes angle C is your right angle for these problems. I'm pretty sure for section 1 they just always put the right angle at the end. Okay, so solve right triangle ABC if A is 23 degrees and little c, so remember capital letters are angles, lowercase letters are sides. So you can draw this however you want. It doesn't have to be perfectly to scale. Oh wait, we want A to be a small angle. Oh geez, I did this way wrong. Okay. So C has to be a right angle. Angle A is 23 degrees. And little c, which has to be the hypotenuse, is 5.8. Okay, so what is the first piece of information that we know? It says solve the right triangle, so I've got to find everything. Well, I know that the 3 angles in a triangle have to add up to 180. So if C is 90 and A is 23, B has to be 67. So we'll do 90 minus 23, 67 degrees. Okay, so I know all 3 angles, but now how do I find a side if I don't have Pythagorean theorem? I need 2 sides to find the third side for Pythagorean theorem. Here's where trig comes into play. So pick any angle you want. So here I'm going to pick angle A because it was given to me. I know I didn't screw it up. So if I pick angle A, from angle A's perspective, the opposite side's over here, the adjacent side's over here, and the hypotenuse is over here. So whenever I set that up, I can solve one of the missing sides by relating it to the hypotenuse and the angle using a trig function. So I can, let's say for example, I want to find the opposite side first. I know that sine of A is opposite over hypotenuse. If I fill in all the information I know, I can break this down to a 1 variable equation because I know angle A, it's 23. Sine of 23. Opposite is side little a, and the hypotenuse is 5.8. Sorry, that A looks awful. I've got to fix it. It's really hard to write on the screen of my laptop with a terrible side. This is what I'm working with right here. So if you look at that equation we just wrote, which the 5.8 is behind my face, I just looked now. But if you multiply the 5.8 over, you have an equation for A. So all you need to do is type 5.8 times sine of 23, which I need to pull up my calculator. Make sure you're in degree mode because when you deal with triangles, you're usually going to be in degree mode. But now we just do 5.8 times sine of 23. And we get our answer. It says round to the nearest tenth for everything on this chapter, so 2.3. Now that we're to the last part of this problem, all we need to do is find little b now. You have some options. Now that you have two sides, you can do Pythagorean theorem to find the third side. Or you can just do what we did again. Instead of using sine, you use cosine, because that would make you use the adjacent over hypotenuse, and the math will be the same. You should get the same answer either way. I will warn you, try not to round until you get to the very end of the problem. Like if you decide to do Pythagorean theorem, don't use 2.3, use that 2.266, blah, 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 whatever. Because we're rounding to the nearest tenth, and depending on how small or how large the numbers are, if you round too much on one number and then round again on your next number, you'll be off by a tenth, and then you're going to wonder why my math lab's yelling at you. So I'm just going to use more trig here. Cosine is going to be b over 5.8. So little b is just going to be 5.8 times cosine 23. So you see how I'm typing in almost the exact same thing. So the adjacent side's 5.3. All right, so we have all three angles and all three sides. And again, you could have done Pythagorean theorem there. You would have gotten the same answer. See, you get the exact same answer. What I was talking about earlier is if you use a rounded answer here. I mean, I don't think it's going to happen on this problem, but sometimes the tenth will be off by too much. No, it didn't happen on this one. But depending on how small or how large, if your number is way, way smaller than this or way, way bigger than this, using the rounded answer could throw you off by enough. You see how they're not exactly the same decimal. So just be careful with rounding. All right, next one. So what if they give you two sides of the triangle? So let me scoot this drawing over a little bit. Okay, so C is my right angle. Little a is 9.5. Little b is 4.3. Now here, I don't have any information about the angles, so I need to do Pythagorean theorem to find the third side. That's one of the few things I know I can start with right now. So let's write out the actual work, even though we've done Pythagorean theorem almost 1,000 times at this point, right? I don't know, how many times do you think you've used Pythagorean theorem in your life? Has to be at least 1,000, right? Okay, so we'll go ahead and pull the square root over just so I can type it all in one go. Here we're adding them because these are the two legs of the triangle. So 10.4. All right. So C is 10.4. And now I have no information about A or B, but I know that it's related to the lengths of the sides. So again, just like the last one, I'm going to pick one of the angles to solve for. So, I mean, we'll pick B this time. So from B, what are the pieces of information I have? Well, I know the opposite side, I know the adjacent side, and I now know the hypotenuse. You can write a trig equation that uses two of those three, and we're going to use inverse trig to cancel out the sine or cosine or tangent, whatever is next to it. So for example, let's see, let's just do tangent. So tangent of B is equal to opposite over adjacent, right? So in this case, tangent of B is equal to 4.3 divided by 9.5. And based on what I have learned from chapter 4, I know that I can inverse tangent both sides of this angle. The answer has to come out of quadrant 1 or 4, but we're dealing with triangles. There's no such thing as a negative angle inside of a triangle, so I know I'm just going to be using the positive answers. So inverse tangent both sides, and we get b is equal to whatever my calculator says when I inverse tangent 4.3 divided by 9.5. So 24.4 degrees. And you could do the work again to figure out angle A, but remember, they're complementary, so you don't have to do all the trigonometry stuff. Just do 90 minus. So A is just going to end up being 90 minus 24.4. So angle A is 65.6 degrees. So there's all your missing pieces. Okay. All right, I'm just keeping an eye out for questions in the chat, but looks like we're doing all right so far. Okay. You've got some word problems toward the end of this. Again, all of these word problems are just going to either... I don't even know what I want to say at this point. It's just going to be a bunch of right triangles again. So whatever your word problem says, however it's worded, if you're doing the work correctly, it should set up a right triangle of some kind. The two vocabulary terms you have to be familiar with are angle of elevation and angle of depression. So line of sight above the horizontal and below the horizontal. So if you imagine a guy or an object or whatever it is, and then if they're looking straight ahead, we call this the horizontal. So if the person looks up, that's an angle of elevation. If the guy looks down, that's an angle of depression. There we go. That's how my geometry teacher taught me how to remember. Depression, so when you're sad, you look down. Yeah. Oh. Okay, I think this is the last slide. Yeah, so let's just do this word problem together. To determine the height of a cloud at night, whatever, y'all can read. I don't have to do this like I do in class. So it says the angle of elevation to the same spot on the cloud from a point located 150 feet horizontally from the spotlight is 68.2 degrees. So straight upward, so you have a cloud. And then you have a spotlight shining straight upward at it. So it's whatever. It's trying to shine. Why am I doing that? Light doesn't do that. Whatever. It's shining up at the light. At the cloud, sorry. So if you go 150 feet away, so here you are. So I am 150 feet away from the spotlight. And then if I look at the same spot on the cloud, the angle of elevation, so you see the guy's looking up from horizontal, the angle of elevation is 68.2 degrees. Find the height of the cloud. So find that height. So notice how, because the spotlight is shining straight up, you've got a vertical side of the triangle, you've got a right triangle. The angle between the ground and the spotlight shining up, the light, is a 90-degree angle. So you've got a 68.2 degree angle, you want the opposite side, and you have the adjacent side. So out of all the combinations of trig functions we have, which trig function uses the opposite side and the adjacent side? Well, that's going to be tangent. So tangent of the angle, which is 68.2, equals opposite over adjacent, h over 150. So I can just multiply the 150 over to solve for h. So you've got 150 times tangent 68.2. So 375 point, I guess 0 here, so 375 feet. So that's how high the cloud is. So, I mean, I know this is all geometry review. It should be a pretty easy topic. But one of the things I notice students struggle with that are in dual credit that haven't seen geometry in a really long time is, if we come back here, this type of problem where you have to use inverse trig to figure out one of the angles. Just be sure whatever angle you decide, just hold firm and be sure you stick with that angle and label the opposite and adjacent correctly from there. The hypotenuse won't change no matter what angle you pick, but just make sure, let's say on this problem I had decided to use A instead of B. The opposite side would have been the 9.5 and the adjacent side would have been the 4.3, and you would have still gotten 65 points. You would have gotten all the correct angles in the correct spots, but the opposite and adjacent labels switch places. So just be careful with that. I think that's the only trick that people fall for on these problems. And yeah, that is it for the lecture. Where is my writing? Did I really just hit discard? Oh, son of a... Alright, I'll write it again off stream. Okay. So, if you have any questions, be sure to email me or let me know in chat at some point. I will be streaming every morning, so you know my office hours will be live on here. I'm also available for the rest of the hour if you have any questions now. Test grades, they probably will not be up until tomorrow, I think. I've got meetings today, and then I don't know if I'm going to be able to finish every single grade on every test. Also, this is going to be really weird for me grading on the computer and not actually having the physical paper to write on, and I'm not going to print out all of your tests. So, okay. I guess I don't see any questions in chat, so we're going to shut this down. And I'll fix this PowerPoint and I'll upload it with this video here in about 10. I mean, YouTube takes about 15 minutes for the video to go up, so I will see y'all later.